Good afternoon, everyone. Myself, Dr. Sugandha Agarwal from the Department of Public and Dentistry will be taking a lecture on defluoridation. Introduction. Groundwater has become a source of drinking water since last few decades due to the scarcity, non-availability, and bacteriological pollution of surface water in many developing and underdeveloped countries. Millions of hand pumps and deep tube wells have been installed in India since 1970 to provide safe drinking water to rural population. Although this drastically reduced the incidence of waterborne disease, it has led to the emergence of chronic health effects in many parts of the country due to excessive presence of chemical constituents like fluoride. Fluoride is a salt of element fluorine. Fluorine is the most highly reactive element of halogen family. Most fluoride associated with the monovalent actions such as sodium fluoride and the potassium fluoride is water soluble, while the one formed with the divalent cations are calcium fluoride and the lead fluoride is generally insoluble. Sources fluoride. Fluorine is in the environment is found as fluoride, which together represents about 0.06 to 0.09% of the earth crust. Fluorides are found at significant levels in a wide variety of minerals, including fluorspar, rock, phosphate, cryolite, apatite, mica, hornblende, and others. Fluoride is a common fluoride mineral of low solubility occurring in both igneous and the sedimentary rocks. Rich sources: water, food, and beverages. Dental products, atmosphere. Poor sources are milk and coconut water. This is the table showing the permissible limit of fluoride in drinking water prescribed by various organizations. This is the concentration of fluoride in medium and effects are this. Factors responsible for fluorosis: the high incidence of fluorosis and its severity depend on the quantity of the fluoride ingested. High fluoride groundwater used for drinking and cooking is the main source of fluoride to cause fluorosis. Consumption of certain locally available foods such as rice, millet, pulses, sorghum, vegetables, milk, fish, eggs, meat, betel, wine, tea, and sea salt contributes additional fluoride. Regardless of the fluoride ingested through food, it has been found that people drinking high fluoride water are prone to severe fluorosis compared to those drinking low fluoride water. This indicates that fluoride is contributed mostly by the water rather than the food. What is the magnitude and distribution of the problem in India? Fluorosis was first detected in India among cattle by the farmers of Andhra Pradesh during early 1930s. In those days, bullocks were used for plowing the land of cultivation. It was the farmer who noticed the inability of bullocks to walk due to painful and stiff joints. The episode was repeated within 6 months when a new pair of bullocks were acquired in exchange of the sixth one. Symptoms of dental fluoride: teeth may show dental caries with cavity when drinking water has less than around 1 milligram per liter. Mild dental fluoride is developed by the fluoride in between 1 and 2.5 milligram. In severe dental fluorosis is developed when fluoride is more than 2.5 mg per. Mild severe types of dental fluorosis. These are the pictures showing the chalkiness of the teeth, brown stain on the teeth, browny wavy striations on the teeth, and severe mottling. Symptoms of skeletal fluorosis: body pain, lethargy, and tingling sensations, progressive stiffness of neck, spine, and joints, inability to squat on the floor. To see someone on side, the patient has to turn the whole body towards that side. To see an airplane, the patient has to lie on the ground. Breathing becomes abdominal gait, and posture becomes ugly, and the bone shows osteophytic overgrowths. This is the victim of skeletal fluorosis with stiffness of neck and spine. In case of where alternative sources are not developed, defluoridation of water is the only measure remaining to prevent fluorosis. However, there are several different defluoridation methods, but what may work is in one community may not work in another. It is therefore most important to select an appropriate defluoridation method carefully. So, what is the water fluoridation? What is it? How it is defined as? It is defined as downward adjustment of fluoride ion concentration in a public drinking water supply so that the level of fluoride is maintained to the normal physiological limit of 1 parts per million to prevent dental caries with the minimum possibility of causing dental fluorosis. Prerequisite is for preparation of comprehensive plan for defluoridation is this. Desirable characteristics of defluoridation: cost effectiveness, easy to handle, independent of the input fluoride concentration, alkalinity, pH, and temperature, no effect taste of water, not add other undesirable substances. Defluoridation methods can be broadly divided into following categories, each with its own merits and limitations: ion exchange, chemical additions, and the membrane-based technologies. Ion exchange methods and ion and cations resin. In these cations, defluoride. shows dust impregnated with the 2% of the alum solution, carbon and magnesium. Nalgonda technique. This is the most important technique with the use of defluoridation. After extensive testing of many materials and processes, including activated alumina since 1961, National Environment and Engineering Research Institute, that is NERI Nagpur, has evolved an economical and simple method for removal of fluoride, which is referred to as an Nalgonda technique. So what is the mechanism of this? Has a rapid mixing, chemical retraction, flocculation, filtration, disinfection, and sludge concentration. Rapid mix provides through mixing of alkali, alum salts, bleaching powder with the water. The chemicals are added just when the water enters the system. Aluminium salt may be added, aluminium sulfate or aluminium chloride, or combination of these two. The dose of aluminium salt increases with increase in the fluoride and alkalinity level of the raw water. Flocculation, subsequently provides gentle agitation before entry to the sedimentation tank. Flocculation period permits close contact between the fluoride in water and polyaluminic species formed in the system. The interaction between fluoride and aluminum species attains equilibrium. Lime or sodium carbonate ensures adequate alkalinity for effective hydrolysis of aluminium salts so that residual aluminium does not remain in the treated water. Sedimentation, it permits a settled flock loaded with the fluoride, turbidity, bacteria, and other impurities to be deposited, and thus reduces concentration of suspended solid that must be removed by the filters. Filtration, rapid gravity and sand filters are suggested to receive coagulated and settled water. In this filter, and settled gelatinous flock is retained. Residual fluorides and bacteria absorbed on the gelatinous flock retained on the filter bed. Disinfection and distribution. The filtered water collected in the storage water tank is rechlorinated with bleaching powder before distribution. Nalgonda technique at household level. Nalgonda technique at community level. Domestic defluoridation. At domestic level, defluoridation is carried on a container of 60 liters capacity with a tap of 3.3 to 5 centimeter above the bottom of the container for withdrawal of water after precipitation and settling. Raw water taken in the container is a mixed with adequate amount of aluminium sulfate solution, that is alum, lime or sodium carbonate, and bleaching powder depending upon its alkalinity and the fluoride content. Alum solution is added first and mixed well in the water. Lime or sodium carbonate solution then added and the water stirred slowly for 20 minutes. The supernatant which is contained permissible amount of fluoride is withdrawn through the tap for consumption. The settled sludge is discarded. In rural areas where people practice domestic defluoridation, stainless steel candle filters adopting Nalgonda technique are used. The advice is to mix the water with the lime and alum and leave it overnight so that the next morning clear supernatant water is used for the consumption. In this technique, besides fluoride, turbidity, color, odor, pesticides, and other substances are removed. Bacterial contamination is also removed. Salient feature on Nalgonda technique, it can be used at domestic and community level. No regeneration of media, no handling of causative acids and alkalis. Readily available chemicals used in conventional municipal water treatment are only required. Simplicity of design, constructions, operations, and maintenance. Local skill will be readily employed. Highly efficient removal of fluorides from high level of 1.5 to 220 mg per liter to desirable levels. Simultaneous removal of color, odor, turbidity, bacteria, and organic contaminants. And normally associated with alkalinity ensure fluoride removal efficiency. Sludge generated in the convertible to alum for use elsewhere. Little wastage of water and least disposal problems. Flexible up to several thousand applicable in batch as well as in continuous operation to suit needs. Needs minimum of chemical and electrical equipment. No energy except muscle power for domestic equipment. Provides defluoridated water of uniform acceptable quality. When to adopt Nalgonda technique? Nalgonda technique is normally adopted when the area under the consideration was absence of acceptable ordinary low fluoride source within the transportable distance. Total dissolved solid below 1500 milligram per liter. Alkalinity of water is to be treated must be sufficient to ensure complete hydrolysis of alum added to it. Raw water fluorides ranging from 1.5 to 20 mg fluoride per liter. Drawbacks: the daily operation requires a trained operator. The major cause of concern with the lime and alum technology in that if the dose of alum is not added to, maximum concentration of alum permitted is 0.03 milligram to 0.2 milligram per liter of water. Reverse osmosis, RO, is a membrane technology that uses pressure to force water through a semi-permeable membrane, thereby removing dissolved solutes from solution based on particle size dielectric characteristics. RO or reverse osmosis can be used as a standalone treatment for most sources water. Besides fluoride molecules, also other molecules can be retained. This is a reverse osmosis. Advantages: it's the best available technique, familiarity with membrane operation separation system, positive public perception. Disadvantage: high water loss due to high source water silica concentration, high energy consumption, high treatment technology capital cost, chemical handling facilities, skilled operator required. So conclusion, even since endemic fluorosis were reported in 1937 and endemic journal welcome in 1977 from India, there has been a remarkable increase in the incidence of fluorosis in the entire country. The only way this treatable disease can be checked is for making available water with a fluoride content of 1 milligram per liter of drinking water and cooking, besides providing nutritious food to people living in the affected habitations. Apart from the adopting cost-effective defluoridation devices, capacity developing a community needs to be addressed for initiating and managing defluoridation devices. Secondly, looking for alternate sources of groundwater with less fluoride is effective. Thirdly, fluoride contamination can also be addressed by promoting foods that are rich in calcium and available locally. These are the alternative measures that can be adopted in projects areas where fluoride is a major contaminant in the drinking water. Thank you.